function of the coefficients of a polynomial equation whose value gives information about the roots of the polynomial. They help tell the number of real solutions to a quadratic equation. Examples.
The given is x squared minus 6x minus 7.
Step 1. Equate the equation to 0. Step 2. Choose the easiest method to find the roots of the equation.
The easiest way to answer this problem is factoring.
Step 3.
You have to determine the two numbers that, when you multiply, will be equal to the third term, and when you add, will be equal to the second term.
In the equation, negative 7 is the third term and negative 6 is the second term. So the two numbers are negative 7 and positive 1, because they would get the product of negative 7 and the sum of negative 6.
So the answer is x minus 7 and x plus 1
equals 0. Step 4.
For you to get the final answer, you have to get the additive inverse of the first term, then let the second term remain the same.
The additive inverse of negative 7 is positive 7, while positive 1 stays the same. Step 5. Classify the nature of the roots. If the roots are greater than 0 and are perfect squares, they are real, rational, and unequal. If the roots are greater than 0 and are not perfect squares, they are real, irrational, and unequal. If the roots are equal to 0, they are real, rational, and equal or double roots. And if the roots are less than 0, they are unreal or imaginary and complex conjugates. So the nature of the roots of 7 and 1 is real, irrational, and unequal.
There is also a way to get the nature of the roots without actually getting the roots of the equation. It is to use the formula b squared minus 4ac.
Step 1.
First of all, you substitute the coefficients into the equation.
Examples.
The given is x squared minus x minus 12 equals 0.
A is equal to 1 and B is equal to negative 1 and C is equal to negative 12. After substituting, we solve for D. Thus, D equals negative 1 squared minus 4 times 1 times negative 12.
Step 2. Solve the discriminant by simplifying.
D equals negative 1 squared minus 4 times 1 times negative 12, where negative 1 squared is equal to 1 and negative 4 times 1 is equal to negative 4. Multiplied to negative 12, positive 48. So D equals 1 plus 48 is 49, and that's discriminant.
Step 3. Classify the nature of the roots.
The discriminant value is 49. It is greater than 0 and it is a perfect square. Therefore, the nature of the roots is real, rational, and unequal. Now you know how to get the nature of the roots in an equation, even without getting the roots, by using the formula and getting the discriminant value.
Thank you, and I hope you learned from this tutorial.